Hello, everyone. This is Ray Savage with Cambium Networks. Thanks for joining us for today's webinar on the PTP 670. The session is being recorded, and we will post it to the Cambium Networks community probably sometime later this morning. We appreciate your questions and comments, and to help us make the webinar more interactive, if you do have a question during the course of the presentation, please use the question and answer dialog box on the right-hand side of your screen. We will get to as many questions as we can during the time period. Without any further ado, what I'd like to do is introduce Sagar Deshpande, who is our product manager for PTP 670. Sagar?
Thanks, Ray. Good morning, everyone. So today we're going to review the PTP 670. This is our latest product line in our PTP portfolio. So the agenda for today is do a quick overview of our PTP portfolio, talk about some use cases, then we're going to get into the PTP 670. Then we're going to talk about some of the features, three main notably is the HCMP and OTAR, followed by the comparison between the PTP 670 and the PTP 650, which is what the 670 is based out of. Next, we're going to provide you some information where you can find more spec sheets and more knowledge to learn more. So this is our current PTP portfolio. So on the left side, we have the PTP 450, which is our 200 plus meg solution, which operates in the 900, 3 gig and 5 gig solution. Next, we have the PTP 450i. This is our 300 plus Mbps solution, which has ARQ, and we also have a version of the ATEX and Haslock. Next, we have the PTP 670, which is our newest product. So this has a max throughput of 450 Mbps. It has HCMP capability, which we'll be getting into a little later on, and it also has DSO, which is brought in from the PTP 650. Also, we have the PTP 700, which is our military grade product. So let's talk about some of the verticals that the PTP portfolio overall addresses. So you can kind of broadly divide them into three big chunk areas. One is the wireless internet service provider area, another is the utility area, and then the public safety area. So the internet WISP or the wireless internet service providers can be broadly categorized into two, which is enterprise service providers to like overall big businesses or private businesses. Also, it can be used for backhauling private sector providers. So like maybe from end customers, you can kind of backhaul it to your main base point. With respect to utility, you have oil, mining, and gas industries. Also, you have electric and water agencies, which kind of require backhauling solutions to collect a lot of data and video surveillance as part of it. For public safety, you can use it for the video surveillance for buildings as well as parks as well as any other monuments. Also, you can use it for disaster recovery as well. So this kind of shows us the global footprint of the PTP 650, which is based on the 670 is based on the 650. And this kind of gives you a feel for the product utility and what it's achieved so far in the past 2-3 years. So these are the countries in which we have shipped the PTP 650, and we expect the same for the 670 as well. This kind of showcases the product footprint for the PTP 450i, which is another flagship product that we have. And this one represents the PTP 400 series. So right now we're going to talk a little bit about each of the three industries. I'll be starting off with wireless service providers. The main advantage of wireless service providers is mainly with respect to point-to-point, is to provide a reliable backhaul solution so that they can collect the information from the customer side and then push it back to their backhaul solution. So to kind of represent this, I want to talk about one case study that we have. So this one is the Mount Everest base camp. So basically, there is a village on top of Mount Everest or above the base camp of Mount Everest, where we have a village of around 150 people, and that's pretty much remote. Like it takes several days of trekking to even get there. So people over there have no access to the internet, and by taking our PTP 650 solution as well as PMP solution, we were able to connect these 150 people to the rest of the world. This helps them with education by supporting their education system. Also helps them with commerce as well as tourism. So the PTP 650 that was used for backhauling over here is proven to be working in really harsh conditions, especially on the foothills of Himalayas. It's really dangerous, especially with the winds blowing as well as due to heavy snowstorms that occur often. So next we're going to focus a little bit about the oil and gas company. So typically when you see oil and gas, you kind of see this picture, which is an offshore drill somewhere middle of the ocean kind of thing. But actually in reality, it looks something like this, where you have a bunch of engineers, a bunch of video cameras surveilling every aspect of this hugely costly endeavor, starting from maintenance side as well as monitoring high-end machinery, as well as keeping track of other surroundings that are going on. The two main factors that come in when dealing with oil and gas or any utility company is security and resilience. Security with respect to physical security as well. Also with respect to cyber security and intrusion detection. Also, different kinds of disaster management are one of the key aspects of critical infrastructure. Another important point is the resilience that we have. So basically, in case of an emergency or fault recovery, how do we go back to the original state? So next, I'm going to talk about a little bit about a company, Aguakan. This is in Mexico City, or just outside, somewhere outside of Mexico. So basically, they had a water utility. So they are a water utility company that works with the Mexico government. So they wanted to provide a better cost solution for, or to basically extend their reach to different parts of the separate county. And they were able to do it using PTP 650, which backhauls the information back to their headquarters. They use PMP solutions from there to kind of branch into different sectors or different areas that we have. So the diagram that you kind of see over here on the left-hand side is their main operation station that talks to a different site, and then you have these a little bit towards the right side. From there, you have their main like sub headquarters, and then you have the headquarters, and then from there you kind of branch out using PTP solutions to remote areas. The third area is the public safety. So public safety is mainly for government as well as disaster recovery, and it's really important. It's a really important aspect of it. So providing video surveillance to monitoring buildings as well as rapid deployment, especially in terms of, for example, today we have, or last week and this week, we have two huge disasters that are happening in Texas and Florida. So having a preparedness or readiness with respect to when the power lines are down, when internet is down, this is the right time to kind of deploy these kind of networks or solutions. So case study for this is we had South Asia Games that was held, I think last year. Last year. So where 4,500 athletes from 8 countries were there in a huge stadium. We provided the entire backhaul solution using PTP 650 as well as indoor solution using CN Pilot, which is another flagship product that we have, and PMP 450 as well. So it was a highly important event where there was no room for mistakes, and the PTP products as well as Cambium products delivered without a problem. All right, now let's get into the PTP 670. So the PTP 670 comes in two main flavors. One is the integrated version and is the connectorized version. So what integrated version means is the antenna is already mounted on with the radio, so you just pick up the one on the left and you're ready to go. Whereas in the connectorized, you'd have to buy a separate antenna and then hook it up to it. So let's think about why we would use a connectorized versus integrated. The integrated solution is like a complete solution. You already know what distance you want to go, and so the radio antenna is designed for most of the use cases that you're going to use. Say for example, you want to go really long distance, you would have to use a different antenna dish which has a really narrow beam width so that you can go a really long distance. So in that case, you would probably use a connectorized and use some of our radios or antennas as well for that. This is the quick high-level spec sheet in a sense of the PTP 670. On the radio performance side, the key highlights are we're going to go into a little bit more detail as we get in through the presentation. But the main idea is the 670 works out of the 4.9 to 6.05 gigahertz. It has a max throughput of around 450 Mbps. It has a channel bandwidth of 5, 10, 15, 20, 30, 40, 45. The bit efficiency is around 10 bits per hertz. It has a SFP port and an aux port. Security-wise, it has a lot of security features, including AES encryption keys, 128-bit or 256-bit. We also have OTAR. That's the over-the-air rekeying support that we have. We also have additional features such as split frequency, HCMP, jumbo frame. Also, we support different kinds of protocols as well, especially 1588 and SYNC-E.
Yeah, Sagar, we did have one question come in earlier about point-to-point. People are very familiar with point-to-point products like our PTP 650. The PTP 670 also does multi-point. Is that correct?
Yes, so that's a good point. So the PTP 670 does point to, so we call that HCMP. It's high capacity multipoint. So, and we will get into a little bit more detail as we go through the slides.
Great, thanks.
So this kind of shows the typical graph chart of the PTP 670. So this maps out all the channel frequencies, the channel bandwidths that we have versus distance. Over here, we have measured it against kilometers instead of miles. The max throughput is 450 Mbps. Spectral efficiency is just over 10 bits per hertz, and the maximum range that we can get to with reliable connectivity is 155 miles.
Yeah, excuse me, Sagar, we just had some folks noticing that some of the slides were clipped. So I think if I show them this way, we may be able to see them a little bit better. So.
Okay. All right, so now let's talk about flexible channel size. So the 670 supports the 5 megahertz, 10 megahertz, 15, 20, 30, 40, 45. You might think that's a lot of different channel sizes that we have, but in reality, when you try to deploy a network outside, the real world it's harsh to find really good spectral efficiency. So you might find a slither of 15 megahertz channel, or maybe 20 megahertz channel, or sometimes 30 megahertz channel. By having more options, you're able to exactly use how much ever you're going to get maximum bang for your buck in this case. So you're trying to get as much bandwidth you can use, so that with increasing performance rather than reducing it. So you're not limited by not having those specific channel bandwidths as well.
Okay, we did have a couple of questions come in, so thanks very much. One viewer is asking, is there a list of external antennas that can be connected with the PTP 670 connectorized radio?
Right, that's a good question. And in this slide deck, we do have a list. Towards a little bit towards the end. We should have the list of antennas that we recommend for the connectorized version.
Okay, the next one is about radius authentication. Does the PTP 670 support EAP TLS radius authentication?
Right. Yes, and we'll get to it more towards the end of the.
Okay.
Yeah.
Well, let's move on, because I think there's some other questions that are coming in that all have to deal with things that we may be working on.
So this kind of talks about the adaptive modulation that the PTP 670 supports. So we do have 13 levels of modulation, and each of this modulation is hitless modulation, which means when you move from one modulation to the next, there is no loss of packets. You just move, you just increase your speed. It's like stepping on gas. You don't stop and then start. You just kind of accelerate. So a simple way to understand it is when you have really low interference, or your channel is really good or clean, you kind of accelerate up to 256 QAM, so you can try to push a lot more data. But then sometimes when you try to get some sort of interference, you kind of slow down, and you kind of go down to maybe 16 QAM or QPSK sometimes. So this kind of shows the antenna pattern that we have for the PTP 670 integrated version. So the gain that we have is 23 dBi. The antenna beam width is around 8 degrees, and the dimensions is 12 inches by 12 inches. That's the size of the antenna that's mounted with radio. So this kind of shows the 4 patterns that is typically associated with an antenna. So you have the azimuth horizontal, azimuth vertical, which is so how you holding it in x-axis, and then elevation horizontal and elevation vertical, which is based on the y-axis. So this kind of to illustrate how it should look as. So now let's talk about channel sizes and what actually does it mean, right? So this one is an example of the FCC regulation. So the PTP 670 supports from the 4.9 band all the way to the 6.05 band that we have. But what actually FCC does is FCC only allows data to be transmitted in the 4.9, 5.1, 5.2, 5.4, and 5.8 band, which is kind of highlighted in red in the middle. So as you can see, the 4.9 band is just 50 megahertz. So this is mainly used for public safety, and it cannot be used for, so it's mainly used for those specific reasons. So you can't use it for backhauling customer data or something like that. So the 5.1 band is the 5.150 to 5.250, which is 100 megahertz. Similarly, the 5.2 band is 5.250 and 2.5350. That's another 100 megahertz. So these two bands are so these two bands are kind of small in that sense. So if you have two 40 meg channels, so you can kind of get two non-overlapping 40 meg channels from each of the bands. So you kind of have 4 options for the 5.1, 5.2. The 5.4 is actually governed by the DFS, which we'll get into a little bit later on. So basically that means is you have to limit the amount of power that you're using because it's in the radar detection zone. So that has a little bit more bandwidth of around 255. But a lot of people use the 5.8. It depends on it depends from region to region, what spectrum you have, and a lot of other factors. But the main 5.8 band is used, so you have less limitation on the power, so you can kind of you can try to get to the max capacity of the radio in that sense and kind of go far distance. So the 5.8 band is from the 5.725 to 5.850. That's another 125 megahertz channel. So this is one of the best channels to use to transmit data. So now let's talk about DSO and how the channel sizes and the regulations kind of fit in. So what basically DSO is dynamic spectrum optimization. So which means, say you're on the 5.8 band, right? So it's about 125 megahertz of space. So let's say so you're already occupying a clean 40 meg channel. Let's say another person comes in, another customer is using same or similar, which kind of overlaps a little bit on your 40 meg channel. So DSO has the option of automatically changing the channels without to avoid interference and without dropping the link. So you're basically automatically you can set the radio to slightly move left or right. Either way, it's going to find the next best 40 meg channel available in that band and then move to that band automatically without actually having any user intervene and change that. So you can also select narrower bands as well. But mainly how it works is the spectrum automatically continuously scans for the realistic interference level that you have at any given point. Once you have a threshold level that kind of drops below your set threshold, you can ask the radio to switch to a next best channel that is available. So using this, you have a combination of up to 2,500 channels that you can use with respect to the small channel sizes of 5, 10, 15, 20 by changing any of their combinations. So this is a typical example of how the screen would look for the DSO application. So on the bottom screen, you have on the top half of the diagram, you have the interference level that's kind of showing with respect to the power, how much it's being used. So you can kind of see the 5.8 band is kind of used up and you don't have that much space available. So let's say, so then you, with respect to this, you kind of move your channel to another band in case there's, in this case, there's a cricket field or like a cricket match going on. So there's a lot of backhaul traffic that's being pushed back. So maybe that's the reason why suddenly you're seeing a lot of interference for that duration of the game. In that case, you can shift off the 5.8 to maybe you can shift within the 5.8 band to another separate channel to use. So the PTP 670 is IP66-67 housing. What means is the radio itself has protection against solar radiation. It has protection against hurricane speed winds. It's already been tested for more than 200 miles per hour in our testing part. Also, it has dust and water protection because we have the sealed encasing for that. And also, it's been tested on harsh weather conditions. So our radios are tested from negative 40 degrees Fahrenheit to plus 140 degrees Fahrenheit. So just a fun fact, the highest recorded ever temperature ever was 137 Fahrenheit. So the green range kind of shows a typical temperature of a typical deployment of a radio, which is probably negative 10 to maybe close to 30 or 40 degrees Celsius. So the radio is way more equipped to handle any sort of extreme temperature or weather condition. Next, the PTP 670 supports spatial diversity. So what a lot of people kind of get confused as to what spatial diversity is and what does it have to do and how does it fit into all of this. So let's ask the first question: when is spatial diversity applicable? So whether we are sending signal over reflective surfaces such as oceans, water, desert, concrete, like concrete roads, basically any smooth surface that you have, the wireless signal bounces off that, and then once it receives your receiver, there's a concern that the two signals might cancel each other out and you might not get any difference, or there might be some sort of multiplying effect, or it depends on the distance. So how would you apply spatial diversity? So what happens actually if you don't use spatial diversity? So the main reason is because of multipath interference. You can either get like a really good signal or really bad, but it's really unpredictable. Let's say a surface of water, right? So you don't know if the tide is up or down, and then all that changes the amount of receiver sensitivity at the receiving end. So how would you use spatial diversity? So the PTP 670 has two N-type connectors. By configuring them and connecting them to two radios, one is the V and then the other one is the H. You can use two paths, so you have two paths of using so that you reach the end receiver, and that's how you configure it that way. So you have you limit the multipath interference by smoothing it out. So now let's talk a little bit about PTP sync and what it means. So when is PTP sync used, and why is it used, and what are its advantages? So let's say you have the scenario, kind of focus on the scenario at the bottom of the screen, where you have two radio towers close to each other on top of a building, and then you have two other radios towards the bottom of another, maybe a lamppost or like somewhere below. So the concern here is, since the two radios on top of a building are close to each other, if there is no symmetry between, or if there's no synchronization between the two transmitting from below the tower, there's a chance that the RX and TX, so basically whenever you're receiving from on top of a building, you might get a transmission from the other radio, and that might cause interference, and that will definitely reduce the throughput of the entire link as well. So the main idea is to synchronize the TX and RX cycles between the receivers on top of a tower and then receivers at the bottom of the radios as well. So the way we do it is by using a PTP sync. And when you connect the two to a PTP sync box that we have towards the end, you synchronize the TX. So at the TX signal, all the radios on the top of the tower are going to transmit. And then when it's the RX duty cycle, all of the radios on top of the tower are going to listen, and then the same thing continues. So now let's talk about a couple of features which are unique to PTP 670. One is the split frequency, and one is the automatic power control, automatic transmit power control. So let's say a typical deployment where you have a blue line which represents your throughput of around 400 Mbps. You found a good 40-45 meg channel, so you're able to send through 400 megs. and you're able to find the blue signal because there's a lot of other signals, like for example in red, which there's a lot of interference from that side. So you just found that one good 40 meg channel that you're using to transmit over 400 meg 400 meg link. Yeah. So let's say another tower comes up a few days, a few weeks, a few minutes later, once you deploy your blue link, which is not, but the radio actually transmits through their radio and comes and affects your radio towards the which affects your radio link. So it drops from 400 Mbps to about 100 Mbps. So there's multiple things that you can do. One is try to find a new channel that you can work with, or it's try to ask the tower of the new guy to change his frequency, which is not possible. So what can you do actually? So the next best solution that we have is splitting up the TX and RX frequencies. So in this case, what we would do is we would use the TX for blue, which means you're going to transmit from the blue and then you're going to receive from the red. So what this actually happens is, because you're receiving on the red, even though you're going to receive channel interference from the blue from the other radios, it's not going to affect the radio, because you're not on the same frequency or band. You're just slightly different. So in that case, you're able to still achieve the 400 Mbps link that you have, but also keeping in track of all this obscurities that happen in the real world. Also, another feature that we have is the ADPC. So our radio actually doesn't power through or like just blast through everywhere. It's a good neighbor, and it only sends how much ever it needs to, so that the receiver sensitivity matches. So if it's closer, you can set the receiver sensitivity to a much lower number, so you transmit less. If it's really far away, or if this thing, you can kind of set your receiver sensitivity level so that you don't disturb your neighbors. So the PTP 670 has a lot of security features built in. We've kind of categorized them into 5 areas: the data security, physical security, process security, management security, and wireless encryption. I'm going to go a little bit more in detail for each one of them. With respect to data security, we have encryption over the air. This is so we have encryption provided, which kind of goes over the air. We also have security feature, that is, you cannot use a modified software other than our firmware. So all our softwares are authorized, so you cannot make an image of it and modify it and then load on top of it. So that's a nice security feature that we have to prevent hackers from getting into by using their own particular firmware. Physical security, so we do not prevent any, so as stated earlier, we don't allow any unauthorized software to be loaded. We encrypt sensitive parameters and configurations, so all of those is protected. And even the unused ports, the SFP and the aux port that we already have, are locked down if they're unused. Process security wise, we actually use the latest, all our products are released and tested well before we launch, and then they're highly, we use the industry's best tools and techniques to test them out before we give it out, before we release the product. So with respect to management, we do have out-of-band management options. We have multiple level access control, as well as we have the identity-based user account, so you can have different levels of serving. So wireless encryption, we have the standard TLS RSA AES 128 into 56-bit key. We also have the over-the-air rekeying capability, which we'll get into a little bit later on. Uplink and downlink symmetric ratios. So right now we've kind of understood what TX and RX is in the previous slide, in a couple of slides earlier. So what actually it means is you have a set duration of transmission and a set duration of receiving. But a lot of times it's not 1:1. A lot of times you want to push through a lot of backhauls. You need to push data one way rather than the other way. It's never 50-50. So the 670 has the option of providing different levels of TX and RX ratio. So some of them is 1:1, 2:1, where you send 300 meg uplink and then 150 downlink. You can kind of, the uplink downlink are you can choose either way. So it's either 2:1 or 1:2. Same thing, we have a 3:1 or 1:3 option, as well as 5:1 and 1:5. We also have an adaptive option which kind of which knows how much data you have and then automatically adjusts so that it kind of best uses the TX and RX cycles. So the PTP 670 works with line of sight up to 155 miles, non-line of sight up to near line of sight up to 25 miles, and non-line of sight using the OFDM technology up to 6 miles. So using multipath, especially in non-line of sight and short distances, using multipath, you're able to get to the receiver in almost non-line of sight zones. So this kind of showcases our radio accessories that we have. So this slide gives you a good picture of the radio in the center and what other accessories that you need if you want to deploy a 670. So let's go from the left in the anti-clockwise direction. So we have the PTP sync that we use it for the sync feature, which we had talked about a few slides earlier. Then we have the SFP gland. So you want to use a fiber port. We have the different types of glands and then software that goes with it. We also have the HCMP antenna. So the HCMP antenna is more of a sector antenna that we use for HCMP capability. We also have LPU, lightning protection kit. So this is really useful, especially and it's really useful, especially if you're putting up the radio on top of a antenna, on top of a tower or any outdoor space, which is definitely prone to lightning strikes. We also have different license keys for encryption as well as 1588 timer and all that. So we have NIDO capability. We have power inject, two types of power injectors. One is the AC power and AC-DC power. We also have a different types of directional antenna if you want to use 2 feet, 4 feet, 6 feet, and 8 feet. These are really useful for long distances, for 25, maybe up to 100 miles, 120 miles. You can use any of the parabolic dishes and then go from there. We also have different kinds of mounting brackets. So we do recognize that mounting brackets come in different sizes because not all towers are the same and not tower widths are the same. So you have to have different standards of mounting brackets to match up with the 670 radios. So now let's talk about the 670 HCMP. So this would be a typical deployment of the PTP 670 HCMP deployment. So you see the red lines indicate the 3 video surveillance. In this case, you have a video surveillance and that you backhaul it to the top of a tower, and then you send a wire across and then you transmit it to maybe a backhaul network or somewhere. So this is how I would explain how HCMP works. So let's consider the scenario on top where you have one HCMP master, which is a PTP 670 connectorized, and you have the sector antenna attached to it. Next, you have 2 remote nodes, RM1 and RM2, which are the PTP 670 integrated. So the gray band shows you the sector antenna and the reach it has, and the brown frequency, the brown lines kind of show you the RX frequencies that we have. So typically, if the HCMP works, the typical frame length or the throughput is around 360 Mbps. So if you divide that into chunks, so say you have it in TDD 1:2 mode, as we had discussed earlier. So you would have two slots for the master and 1 slot for the remote node. So you would have 2 slots for master for remote 1, and then you have 2 slots for master for remote 2, and then you have 1 slot for remote 1 and 1 slot for remote 2. The same thing applies if you are doing TDD in 1:1 mode, where you have so you have 4 slots altogether. So 2 masters, 2 for remote 1, 2 masters for remote 2, 2 slots for remote 1, and then 2 slots for remote 2. Of course, this is an illustration, and this is just to kind of get you an idea of how we divide our throughput capacity amongst the masters and the remote nodes that are connected to it. So HCMP using Link Planner. So Link Planner is our flagship software tool, which is free, and people around the world use it for planning their links. And this is their step 1 to provide a link planning solution. So this is like the step 1 that people take. So we have options of using a Google Maps to map out their entire network to kind of see how it would fit, what kind of interference that you have, at what elevation do you need your antenna to be. So we collect this data, so we map out using Google Earth. We also take in elevation into account. So in this kind of example, we see a point-to-point between between Park Lane Elementary and Westminster Lane. So we have a distance of around 19 miles. We're using a PTP 650 in this case, but then you can use a different band that you want to select, and then use different modulation rates that you have. You also have the option of using different interference, and you can also have the option of changing the radio antennas to see what kind of throughput or gains do you get. At the bottom of the performance summary, you get the link budget that you are going to get, the aggregate IP throughput that you're going to have, as well as the mean packets per second as well. So this kind of shows you a typical deployment of HCMP and how it would work. So the HCMP is one master that connects to 8 remote nodes. So in this case, we have one master connecting to 3 nodes, and this is how you deploy in a link planner tool. So the table on the left shows you what the throughput is for a 20 meg channel and a 40 meg channel for HCMP. So HCMP comes in right now, it's only supported under 20 meg and the 40 meg. These are the symmetric options that we have, and these are the throughputs that you're going to get. All of this information is available on our website as well. So how should a HCMP link look like, and what are its advantages? So let's say you have a deployment of 4 radios, 4 radios using either a HCMP node or 4 point-to-point links. So if we compare the number of radios required in the point-to-point mode for 4 links which are close to each other, you need 8 radios, whereas in HCMP mode you just need 4 radios, because you just need the 4 PTP 670 radios and 1 670 connectorized with the HCMP sector. The number of radios and the antennas you'd use is again 4 and 4, because you'd use four antennas for 4 of them as well. Whereas in the HCMP case, you just use 1 sector antenna, which also eliminates a lot of alignment issues that you have. As long as you point it in the right direction, the HCMP mode should make it much easier to align the 670 radios. Also, the power drawn is limited or less compared to the 4 radios. So you basically have 1/4 the power that you would normally use for the same deployment using point-to-point as well. So let's focus on a little bit about how to enable HCMP. This is, I know, a little bit more in detail, but just to get a feel for how it works. So one thing is the PTP 670 in the diagram. So basically all the HCMP master and slave should have the same group ID. So in this example, you have shown the group ID highlighted in the below picture at the bottom right as a 0. So you can have any number from 0 to 255. So that kind of represents your unique group access ID across your HCMP master slave combination. You also need to buy a HCMP license, but this license is only required for master. So in our case, where you have 1 HCMP master and maybe 4 or 3 HCMP slaves that you have, you just need 1 license key to enable HCMP feature. So the HCMP master has a license key, but the HCMP slave is free and built in by default, so you don't have to pay for that. So let's focus quickly on OTAR. So OTAR basically is the secret key used to encrypt over-the-air data that is automatically generated and seamlessly applied at preconceived intervals. So basically, you don't have to change the encryption key every time by a user. This is automatically done using our OTAR software key. So now let's focus on the PTP 670 versus the PTP 650. So a lot of us are familiar with the PTP 6. A lot of you guys are familiar with the 650. So the 670 and the 650, the radio performance is the same. The radio price also is the same. We have a better antenna dish. So the 650, if you remember, has a 14 by 14 size, whereas we have kind of reduced it down to 12 by 12. So that's a 1/4 introduction of the size of the antenna. So so PTP 670 supports HCMP and can kind of connect up to 8 nodes, whereas the 650 does not support HCMP at all. Also, the 670 comes with full capacity key by default, so you don't have to pay for the full capacity license key. Whereas the 650, we had to start with light, and then you had to buy a key to get it to full capacity. In this case, the 670 comes with full capacity key by default. Also the number of hardware variants. So the 670 comes only in connectorized and integrated, whereas the 650 comes in, used to come in the connectorized integrated PTP 650S and 650L. We have also changed the mounting bracket to a much more solid and ruggedized solution that we have here compared to the 651. So let's do a quick overview of what 670 is and what are its benefits. So mainly the 670 has a much better or faster processor than the 650. So that allows us a lot of memory power and juice to basically develop better features, one of them being HCMP, but we hope to do a lot more in the coming future. So the second one is it is HCMP compatible. You can connect up to 8 remote nodes, and it has a really high spectral efficiency connecting even in that space while connecting that as well. Next one is the pricing. The hardware pricing of the radio is the same. So PTP 650 pricing is the same as the PTP 670 pricing, and it's a one-to-one mapping of each of the product lines that we have. Also, there is no license fees to enable full capacity on the 670. Oh, now it's the important part is the compatibility with the 650. We had a lot of questions asking, is the PTP 670 compatible with the 650 and vice versa? And is HCMP working in the 650 or not? So the answer is the 670 can work with the 650 using a special firmware release that we're going to launch by start of Q4 of 2017. So that's probably in 4 or 5 weeks. If you put that software on the 670, that behaves exactly as a 650, right? So it is backward compatible, but it's not forward compatible, which means you can't take a 650 and make it work with HCMP. So you can only make a 670 work with the 650, right? Also, the PTP 670 are currently available for ordering. Please contact your local distributor for more further information as well. So for more information to kind of learn more about our products, please visit us on cambiumnetworks.com. So we have a lot of resources here, spec sheets, case studies, white papers to help you understand more about the product, more about the use cases, and how it's already being deployed in the real world. Please also visit our community forum. We have a very strong, vibrant community over here. So where in the forum people post questions related to whatever they are either seeing in the field or like some sort of field issues, and then we try to resolve it. We're pretty quick about it. So within a few hours, you definitely will receive a response. We also have something called a knowledge base in the next tab next to the forum, if you can see on the screen. So this knowledge base is really useful for people just joining into your company or people who are not familiar with it. The knowledge base provides you like a starting guide or like quick FAQs about Cambium products. This includes PTP as well as PMP, CN Pilot, and all the other products that we have. So mainly people who are just getting started or just want to understand Cambium networks and kind of get to it. We have a lot of material over here to help you get started and get you on par with everyone else relatively quickly by kind of going through our PDFs and video tutorials. So also we have in our forum also you can communicate with other network providers around the world, talk with them, and then share ideas as well as you can submit your development ideas, also your real world connective stories as well. Also, please follow us on social media for getting more and latest updates on what next endeavors we have. And for more questions, please visit our community.cambiumnetworks.com. And yeah.
Okay, thanks, Sagar. We do have a lot of questions that have come in during the course of the webinar this morning, and we will try and answer as many of them as we can. What I'm also sending you right now so that everybody can take a look at it is just a quick survey for how you felt about this particular webinar. So you can do that either now or later, do it at your convenience. You should be able to see the link right on your screen there.
The survey helps us to make better content so that it helps you guys to get the information that you need. So please take a few minutes to fill out the survey. It really helps us out in providing better content next time.
Okay, Sagar, the first one we have is the PTP 650, will it be able to connect to a PTP 670 as a remote node?
The answer is no. So the PTP 650 cannot work in HCMP mode. So you cannot use it as a remote node in that case. You can only use it for point-to-point mode. You cannot use it for in HCMP mode.
Okay, the next question that came in from Mohammed, is there any available training course for the PTP 670? And if yes, where can we find out about it?
So we have it on our community. It's on our community page as well as the website.
Yeah.
We do have. We also post the training sessions and the timings that we have.
Right, and you can find out about PTP 670 training or training on any of our products by going to cambiumnetworks.com and then select resources and then select training, and you'll be able to sort it by region and also by product. This question came in, can the PTP 670 work with Cisco routers to provide radio aware routing?
Oh, that's a really good question, and the answer is yes. So if I go back to a few slides before, so we do have the MAB capability. So that's another license key feature that we have. So we do support that.
Okay, this one is about antenna files. And are the antenna pattern files for integrated antennas available in common formats so that they can be used by third-party prediction tools?
So we do have the antenna patterns up on our community page. So I think you should be able to find it.
Yeah, and as far as planning tools, we certainly recommend that you check out Link Planner as a tool to use as you plan your networks. It's available for free. You can download Link Planner, and it is all geared up and ready to go with PTP 670. The next question is, how does the 670 radio perform when you in a fast-moving ship? Do you use the BATS stabilizer?
Yes, it does work with the BATS stabilizer, but it depends on the range of the radio. It depends on a lot of factors and difference level that you have, the speed of the boat, and but it does support it.
Okay, the next question is about dynamic spectrum optimization, DSO. How does that perform in environments with high interference across a band? So will it continually retune? If so, how often does it retune? And does this negatively or positively affect total aggregate throughput?
That's a really good question, Will. So basically how DSO works is the user gets to set a threshold. We already have a default threshold set in. So if the user can set in a threshold of, let's say, -70 as the noise floor. So if the signal falls below, just an example, -70, the DSO kicks in to search the next best channel, and then automatically, without losing even a packet, you just move on to that next one. So the user has an option to select the noise floor and how long does you want to do before retrying again. So you can either select a few minutes or you can select 30 minutes to kind of see, to gauge, because you guys are the best in your environment to kind of see the interference level. We also have the spectrum analyzer on the 670, which helps you track the past 24 hours or maybe 48 hours, or you can kind of map how many the last 24 or 48 hours that you want to see the network interference level as well. So based on that information that you have collected so far, you can kind of predict, like, let's say for this network, for this environment, I'd probably wait, maybe it's like a sporadic thing for a few minutes, so I'd rather wait maybe 5 minutes and see if it makes a difference or not, and then make the change.
Okay, and Nirmal has a question about spatial diversity. I think in the diagram you were showing 2 radios on each end. For spatial diversity in a PTP setup, do we need to have 2 radios on both sides? For example, if we have a PTP 670 on 2 ships trying to connect to each other?
That's a good question. The picture that had deployed was, one was a ship and the other one was a port. It also again depends on the network conditions, but typically it's better to have, it's much more reliable if you have two antennas for each radio on both ships, just so that you get better reliability even if you go a little further away.
Okay, and Tony is asking about uplink and downlink symmetry. Can you adjust the uplink and downlink symmetry when using PTP sync?
Yes, so you can definitely adjust. In the diagram that I'd shown, I just put it as 1:1, but you can definitely configure. So the configuration when you're using PTP sync. So PTP sync, the main functionality is just provides a pulse, and then it says, okay, this is the time you start for this duty cycle, right? So for this entire cycle, this is where you start. So, but you have to program both the radios to so that they have the exact uplink downlink ratio in this case. Only then it makes sense to use a PTP sync.
Okay, and Harvey is ready to buy. He goes, he says, I'm facing long lead times on both the PTP 650 and the PTP 670 connectorized radio orders. This is the peak time of year to get radio and antenna tower work accomplished, but I'm not able to obtain the radios for many weeks. Can you comment on the lead time issues and whether they're going to improve?
So I don't know if I should be. So we have received a lot of positive feedback and a lot of orders for the 670 because people really like it. So that has put some constraint on the demand, but we definitely are getting through them, and for sure you should definitely have all the radios within 2 weeks of the lead time is probably 2 to 3 weeks once you order that.
Hey, here's one I can answer. John is asking, are we able to get a copy of the slides in PDF format for future reference? Absolutely, yes. I will put a PDF of these slides up on the community probably in a few hours with the recording. So you will be able to have a complete copy of the presentation there. This one is going back to ships at sea kind of thought. And I'm going to guess the answer is it depends. But the question is, what is the maximum range of the link when using the highest gain bat stabilizers in ocean and expected speeds?
So you're right, Ray. It depends on the type of antenna, the gain it has, and a lot of other factors. So it's a multiplying effect, right? So you have different speeds and then different antenna sizes and then different gains from that, and so you have to use the link planner and kind of get more information out of it.
Right. Another question here is about IPv6 routing. Does the PTP 670 use IPv6 routing? And if so, what protocols are supported?
Right. It does support the IPv6 protocol, and it supports any of the other features that are associated with it as well.
Okay, and Juan asked this question earlier, and I didn't answer it correctly for him, so I'll ask you right now. Juan is asking, does this support dynamic filtering?
So dynamic filtering is a flagship feature set of the 450i, but we have an equivalent feature of dynamic filtering in the 670, but it's not the same as the 450i, so we do have filtering.
Okay, let's see. In PTP mode, what was the maximum distance tested and with which sector antennas?
So the maximum distance that we have tested with the point-to-point, this is for the 650. We haven't had a chance to test with the 670 because it's the same radio performance. We can kind of say we have tested it up to 155 miles using two connectorized solutions with two antennas. I can't remember correctly what the gain of the antenna was, but yeah, but I think the distance-wise, I'm pretty sure it's 155 miles.
Yeah, and the sector antenna means you're operating in multi-point mode.
Right.
So, yeah. Okay, we do have a couple of other questions about people who need things emailed to them. We will answer those offline and take care of that. So what I'd like to do right now, make sure that you do take the survey. We sent out the link for that. And we should be able to post the recording to the community and also a PDF of the slides sometime within the next couple of hours. So that'll all be available on the community. And the URL for that is community.cambiumnetworks.com. Go to the PTP area and you'll be able to find it. Thank you, everybody, for attending the webinar. And thank you, Sagar, for your information on the 670.
All right.
Thanks, and we'll see you later.
Thank you.